Hello and welcome friends, my name is Aditya Pawar and let's start our series to the universe. So in this series I am going to again introduce a series of black holes which I have already introduced already, but that was some basics. So if you guys are interested in some technical series, I am going to start in a technical series of black holes. So in the main focus I'm going to talk about black holes. So what are black holes? Black holes are a region of space-time where the space-time fabric or curvature of space-time is curved to infinity, because according to inflationary theory we have understood that space-time is not a flat surface, but hence it is a three-dimensional surface. Hence any object which have mass also has proportional to gravity, and any object that has mass also has some gravity. Hence they curve the curvature of space-time. As we go towards black holes, they have an immense gravity which cause immense curvature of space-time according to Einstein's solutions of field equations. So at the introductory I am going to talk about black holes. So at the black holes they have three types. That first they are primordial black holes, second they are intermediate black hole, and third they are supermassive black hole. The first type of black hole are primordial black holes. So primordial black holes are the smallest type of black holes known to humankind, and it is also known that it may have been existed as the dawn of the universe or the starting of the universe, as quick as universe has formed. So these black holes are around 0.1 to 1 million solar masses. These black holes have a radius of Schwarzschild radius Rs is equal to 2m divided by c squared. So this is the surface boundary or Schwarzschild metric, as we call, of the black hole. So as we continue toward, my main goal is on Hawking radiation, which was proposed by Stephen Hawking in the 1974. So as Hawking was doing this, he thought that black holes would have been emitted some particles and antiparticles which may have been there for the entire universe. That the as you understand of the event horizon, the as any matter goes into the black hole, they get stored at the event horizon. The information of how the color was, how its charge was, what matter was there, all this information was surrounded in the black hole event horizon. But as black hole ages, as it is 1 million, a billion, trillion years old, it gets to doze off its energy, and as it have gulped so much of space, it starts to radiate this energy in the form of thermal equilibrium. As we know from the second law of thermodynamics, that as the area increases, the entropy also increases. As the area decreases, the entropy also decreases. Hence, as the black holes have formed and go to evaluate their higher stage, they inflate inside because they have sucked in a lot of matter. As they get old, they seem to radiate all the energy. This can be seen as through the light cones. So a famous example of that is, imagine a diagram. You have one straight curved line, a Euclidean geometry, that there is a surface of a event horizon, and then the center line is singularity. As some light rays are reaching the black hole, they directly go into the black hole. But there are some light cones formed, which some of them do go into the black hole, so pass the surface of the black hole, and some of them try to escape the black hole. So this phenomenon is known as escape velocity in black holes. But this phenomenon is hypothetical because it would violate the Einstein's mass equivalence theory. So according to Einstein, he said that E is equal to mc square. So that c squared is the speed of light, which is the fastest moving object in our universe. According to him, speed of light was the fastest moving object. But in this escape velocity, we could escape from our black hole. This would be that we have to travel around the region of the black hole so fast that it is more than the speed of light, as you all have understood it from tachyons, but they are also an hypothetical particles, not proven fundamentally or physically. So as this event horizon evaporates, it leaves out some information of the black hole or some information of the observer or anything that was there. As this Hawking radiation does that, it is also called as quantum black holes, micro black holes for mechanical black holes, and quantum effects of a black hole, which are according to the laws of thermodynamics. Because black hole gives off radiate, hence they give off heat or gives off heat and light, hence they radiate. In this Hawking radiation, there are two phenomenons. One is the information paradox and one is the grandfather paradox. So in the information paradox, all the information which have been sucked into the black hole through so many years, 1 million or 2 billion, so many years, they have stored this information into the event horizon. As the black hole gets aged, it loses off some of the information by bit by bit. Hence, as it does, the density of the black hole gets lower and lower until at a single point it vanishes. So many of us or many of you have been decided then what will happen if that reaches an ultimate point. Where will the singularity go? So that singularity which does not have a protected boundary of the black hole, which is event horizon, doesn't have it. They are called naked singularities. These naked singularities formed at the very death of the black hole, before the very death of the black hole. So they take a lot of years to go to there. As to black holes, this Hawking radiation was mainly popularized because of black body radiation, which I will deal with another concept in another video. So this was of Hawking radiation. Then what will happen to observers at the black hole? This is the second most main question around many people who are intermediate learners or basic learners. So as you and your friend both are observing a black hole, you decide to go into the black hole to break down the physics and understand the underlying physics beyond this event horizon, because it has not been used, because black holes do not allow physics to use in them, because they are very weird and abstract objects. Hence you decide to go into the black hole. So you both have time clocks. So as you are going towards the black hole, according to Einstein's field equations, near the black holes you have immense gravity, pressure or gravitational attraction appointed on you, but not on your friend observer. So as you go toward the black hole, the time for you gets slower and slower, but the time for him remains normal. As you go towards, the friend observer will also see you. So as he will see you, you will get to the microwave length, which is an electromagnetic wavelength we have already learned about. So in that we only see our visible colors, but as you are going towards the black hole, you would begin to get more expanded because the color reaching you from your observer or to your observer is getting more stretched and more stretched because of the immense gravity, that at a point the your time will be is equal to 0. So t is equal to 0 and your friend's time will continuously do there. So as you reach this singularity of the black hole, your time would be stopped or frozen time, and his time would continuously do. So you can also send the information according to the theory of escape velocity, but if you have so much speed of your information that it would be faster than light, but is so much fast telecommunication, but it is not possible for in real life. It can be predicted in theories. So to summarize this all, we have understood that Hawking radiation means that it is the thermal equilibrium or thermal radiation given out of a black hole as it ages over the time. As this phenomenon does that, the black hole slowly vanishes into nothing. Hence, all the information as a star has evolved, because all the black holes have come from the stars or the merger of black holes. Also, a new way of physics in 2014. So, if you want to see my earlier series, click on the I button here, and stay tuned for more videos. Like, share and subscribe to my channel for future updates, and comment down below how you like the video, what are the questions for this technical series which I am starting, and how do you like the technical series of my lectures. So please stay tuned and peace. Thank you.